We still have 9 minutes, and consider this as a sound check, and we will again try later if the sound is good for everyone, and then let's start in punctual at 2 p.m. German time. So hello again. For those who can hear me, please just write in the chat if you can hear me properly or not. Okay, it looks like people coming in quite quickly now. So we already have almost half. That's fine. Welcome to the Snom webinar. As you can see, the title is slightly different to your invitation, but it's still the same. So it's just it's more the term which is used very often these days. So we have today the Snom M900 multi-cell and location-based services. And there is some focus about location-based services because this is what we do with our new products, M9B and M9T. And we use beacon technology. So there's a bit of housekeeping, unfortunately, because I'm alone today. So my colleague could not join. That means that questions, I might not see questions immediately. So I will try myself very hardly to stop to check if there's questions. And please, if you have a question to a slide which is really burning, do not hesitate. I will go back to the slide if I miss it somehow, but I will definitely try to answer your question, because it's here is really important that we all will be on the same picture. Okay, so let's start and see what we have. So the main thing is actually history. You know Snom phones, I'm sure, because you're in our webinar. You know that our desktop phones are quite popular for 15 plus years now. And 10 years maybe, 10 years ago, we decided we need something in the mobile space. And of course, if it has to be mobile within a typical office environment, because at that time we were focusing almost completely on office equipment, Wi-Fi came into our mind. So why not have a Wi-Fi phone, which is really cool, and Wi-Fi was popular anyway. Everyone has Wi-Fi infrastructure, blah, blah, blah. We tried that, but we always failed with the battery life. Battery life was terrible. A Wi-Fi phone had to be very heavy, very big, bulky, awkward to have enough battery life to actually survive a normal voice call. And since we are voice people, and we are really picky on voice, so if something is like click, 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 or whatever robotic voice, we don't like that. We just gave up. And I'm not sure, maybe a year, 2 years later, we decided we go for the 35 or more years known technology, DECT, and we do a DECT IP. DECT at that time in the US, for example, was almost unknown. Even though it's so long time around, and but in Europe, especially Germany, every hospital had the DECT system. Why is that? Very simple, super reliable. Battery life is just good enough. There's some sort of encryption which you can also accept even as a security guy. So we decided to go cordless telephony with DECT. Okay. So, but that is Office. Immediately after we've released the first version of it, at that time a single cell, people came, we need bigger systems. Okay, so we needed a multi-cell. Multi-cell in this case means many bases or antennas, many handsets in a real large environment, for example, the hospital or a big production environment. And so people wanted to have a cordless telephony really for difficult environments, not just for offices, but for something more advanced. More advanced for us means painful support, etc. But we went through all, and we actually managed somehow. And after we managed to have a large running multi-cell system based on DECT, good enough SIP to who knows almost all major PBXs. Yeah, FreeCX is just one of them, which actually complies to our equipment. We understood again from customers, which is good, that they are in difficult environments, and in those environments, very often they have professional alarm systems. So what is an alarm system? Yeah, well, it can be everything. Pressing a button, the typical fire alarm can be intercom, so like the panicking, the panic mode, when all phones shout, you go out quickly. Someone with a weapon is inside the premises, etc. So it can be everything. But the main thing about alarms is that behind this alarm, there's a professional handler. There's a professional company which developed a software which gives all the standards you need to follow, the reliability for such systems. And especially in a hospital, an alarm can definitely save lives. So an alarm system needs to work. Our customers ask us, can we have something for a hospital? And of course, the answer from Snom is no, because we have no clue how to do that. We have no clue about all the different certifications you need and all the legacy systems you need to connect. So that didn't work out quite well, but there's so many alarm system manufacturer. So very smart companies. Some of them, they exist for who knows decades. Others are quite new. And we just approached them. They actually also came to us and tried to understand how what would it take for them to use our devices as just one other device on their professional alarm system. So as you might know, we do have, or we had for years and years, we had already a handset, M85, which could understand if people fall down or they are not moving anymore. So like the typical man down hardware we had already, but no proper alarm system behind. Okay, so what we did at the end of the day, we actually talk to the right people and try to make a solution. Here, as just as a quick overview, the M85 to the very right is the one which I just mentioned. Yeah, it's quite a heavy, super how to say IP65. You can throw it around, so it's really sturdy device. This one already had a gyro inside. That means if it falls down, it will be able to send the so-called unconscious alarm. Yeah. And so with this one we started, people liked it, and then you can see if you go more to the left, M65, the typical office phone, the old one. Then of course we have something like M15, which is half GAP compatible, super simple single cell system, which you cannot use for alarms simply because this is a typical home user thing, and M25 but then the real important and the real interesting devices came. This is the M90, M80, and M70. Why is this so important? First of all, they all have an alarm button for the so-called conscious alarm. So if I know something is wrong, I press the red button. Okay, so big deal, let's say. But they also have more improvements. They are really shock resistant from the beginning, because of course we got some complaints in a rough environment that, for example, an M65 is not sturdy enough. So shock resistant design as a must, let's say. But there's one more thing. Since we were focusing on alarm, we also had to focus on something which gives us a position. So where is the phone at what time? And that's why they all can do Bluetooth to headsets, of course, yeah. But more important, Bluetooth as a positioning system. So Bluetooth, the device sends us a Bluetooth beacon to basically say, I'm here, I'm here, I'm here, and then somewhere there must be a receiver to say what to do. Okay, so let's say from the very simple office phone, we went to a very nice IP65 device, which could actually find out if we have an unconscious alarm or not, up to something which gives us a position. And let's just go on further. So for the typical, let's say, hospital, big, many buildings, we could easily provide this, a solution together with professional alarm system vendor. Alarm system vendors, by the way, for some reason, at least in our Europe region or extended Europe region, most of them come from Switzerland. Who knows why? Maybe because this is really something which needs to be precise as a Swiss clock. Who knows? Yeah, that's good for us because we speak minimum one common language, and yeah, whatever alarm server company you might know in your country, let us know if we can do a partnership with them to make sure that our multi-cell system works with their alarm system, because then you already have a solution for something like a hospital, something like an elderly home, something like an industrial whatever thing which needs conscious and unconscious alarms. Just think about that. We will help here. So, but of course, you know, customers, yeah, they like that we have communication in difficult areas. They like that we had alarms, but they were not happy about the location. And they needed solution which gave more precise location. So if an alarm happens, I can tell with a DECT system, he's somewhere near the last base. But as you might remember, let's take a simple office plan detail. If you have, let's say, M900 deck bases like those two, they build their own cell. Then they can actually see or use a huge space. So we try to show that with the circles. So there's DECT is simply, it's very interesting how far the signal goes. Yeah, so the typical DECT range is in an office is, let's say, easily 30 meters, 50 meters. Outside can be 100 meters. We manage once 300 meters in a fully open space outside. So that means if you are somewhere near such a base and something happens, then you know definitely something happened because you are registered at this base, so the left one, for example. But you could as well be at that position or any other position within the range of the base. So it's a huge space. So it's not precise. You can say it's building whatever, potentially floor 1 or 2. Or maybe you're lucky, you have very hard emergency doors where even DECT can go through very badly. Let's say, then you can say, yeah, they are in corridor 5, they're in corridor 6, but that's about it. That's the position you can give, and depending on what you have as a use case, this position is just not good enough. So they ask us to get more. Okay, how to do that? Naya. So positioning in general, if you use Google, is of course nothing new. Yeah, we know from our navigation system that at least global positioning system is used for everything imaginable. And but indoor positioning in companies is also not new, but somehow it's not that popular. But if there's an indoor positioning system, it's mostly based on Bluetooth technology. Just look at the Apple tag things. They based on Bluetooth and other their own technology, slightly different to what we use. But yeah, this is it's very common to do that. So the good news about Bluetooth is, if you want to reuse the technology, there's already something like Bluetooth Low Energy. Bluetooth Low Energy is exactly what it means. It's not just a typical Bluetooth connection to whatever server or to whatever device, but it's a very low energy connection, which is basically a sort of ping. Just I'm here, and in the picture you can see here, we have a Snom. So where's my mouse? Let's just see if my mouse comes back. Okay, here's my mouse. Nice. So let's just say if we have the big guy here, this is a Bluetooth low energy beacon receiver. So I need something which sends a beacon which says I'm here, I'm here, I'm here. Just take one of our new handsets. You can enable that they send position every time. So whenever an handset is near this, let's say, receiver, the receiver will find out, oh yeah, there was a device and it was away something like, who knows, 2, 3, 4, 5 meters, and so you know that there are devices near my receiver. Very simple thing. The little buttons here, these are actually tags. Tags you can stick to objects, and they do the same. Whenever you shake them, because they have a motion sensor, whenever you shake them, they say, I'm here, I'm here, I'm here. And after a while, because they cannot get an answer, they just say, I'm here, I'm here, I'm here. After a while, when they're happy and no one is shaking them again, they go silent, which is very nice for a couple of applications we show in a couple of minutes. So then just to go a bit deeper into the receiver thing. So the important bit is not that Snom has a beacon receiver, because a beacon receiver, just use Google, everyone can do. Of course, everyone has it. And everyone has a solution with beacon senders and receivers. The beauty about what we do is that we have a beacon receiver, which is part of a multi-cell. So this thing acts like an antenna, basically. So you can put it within your, for example, hospital at any point, at any location where your multi-cell still has coverage. And that makes it very, very flexible. The only thing you need, because that's the, let's say the positioning is via DECT, and then the Bluetooth reception is Bluetooth. So of course you need a battery. So the only thing you really need is a power source. That's it. So you just take the thing, put it somewhere where it's important to know that here is an important position. If someone comes, it needs to be alerted, and you just put it there. So that's the real beauty. So we often get the question, Naya, so you do Bluetooth but everyone does it. Yeah, but not everyone combines it with DECT. And that's the most important bit here. So let's try to remember that. So what can Bluetooth do? DECT, you know, is 50 meters, 100 meters, very, very large spaces. And Bluetooth makes almost the opposite. It's very small spaces. So here it says device recognition within 50 centimeters and 15 meters. That's actually quite true. Bluetooth around 1 meter distance is normally best. The further it goes out, for example, 4, 8, 16 meters, it gets very you cannot really rely on the distance, but you can rely on that it's further away. Let's put it that way. So a typical Bluetooth installation is either something which is very, very which has an application very near. For example, if I want to have something under my table which recognizes that I'm actually sitting at this table, then I have maybe a reception of only 1 meter. That makes sense, because then I can say I sit at my table. But for example, in an elderly home, I want to know if the patient or the person is actually inside his room. The room can be bigger than 1 meter, and you cannot assume that anyone goes near a receiver just to log himself in. So like typically as access control, you cannot assume that in an elderly home. So in this case, you have a receiver in a room, and the receiver looks in this 15 meters range and just checks who is the best and nearest in my proximity. And like this, you can already do a very nice system, which gives you a good indication, almost a guarantee that someone is in the room or not, who carries, for example, a special necklace which sends beacons. Yeah. So the thing has also 4 integrated antennas. Why is that? We can see that later. Very important, like I said, it has a power supply, because we combine 2 technologies, DECT and Bluetooth. Both need the battery and power. The thing can be battery powered, but in this case, it's really more like to make sure that it's uninterruptible power. So if the power source, the global one, let's say, breaks down, then the battery will easily, maybe in a full working, permanently working system on DECT, can maybe last 2 weeks, something like that. Yeah. And most important for all the people who know different equipments, our beacon technology is compatible with the main beacon types which are existing. iBeacon, of course, is Apple. AltBeacon, I guess, is Google, and Eddystone is who knows whom. Yeah, and that means when you already have equipment which sends out beacons, it's very important, sends out, not receives, sends out beacons, then you can reuse this and just use our Snom receiver within the DECT system, and you already have a device on this position in my DECT, blah, blah. Yeah. So very nice. So let's say maximum compatibility. So let's see, what does it mean? So first of all, you see the ugly thing, means no network. Why is that? the receivers, when we place the receivers within our environment, then just remember, we can place them anywhere where the DEC multi-cell has coverage. So very, very flexible. We need power still, yeah, unless it's you want to use their position more than 2 weeks, which is very likely. But you can place it everywhere. You do not need any extra network. It's anyway DEC connected, so you have the network perfectly done. So now, since it's a Bluetooth receiver, it has its own reception area. And as you can see, we have the typical, let's say, what can it be, half spheres, or in this case circles. That means they have a round reception area. But since we have 4 antennas, we can force our receiver to look more to the left or more to the right. So, you know, there's always a nice, in audio, there's always a nice term, beamforming. It's a bit similar. So basically you skew with your 4 antennas, you skew the reception to one side or another, depending on where you need. And we have one small example here where it's really needed. So if this, for example, is an entrance or exit door, then it would make sense that this beacon receiver is not looking above, because above is still inside, and you don't know if someone goes really out of the office or is still in the office. So that's why you basically adapt the antenna to look more to the left in this case. Yeah, that's what it is for. In practice, quite honestly, we almost never really use that. It's interesting, yeah, but somehow the typical default thing in most cases, definitely in the elderly homes, or this thing, for example, looks in one room, this looks in another room, this one is a working place, which is has a smaller area, etc. So you don't, at least in our typical project, we do not have to adjust it, but we can adjust the direction. That's important to know. Okay, so if again there's one guy here, there's an alarm, then he will be the receiver will receive his basically beacon, in this case our handset, for example, which permanently says I'm here. Then it will transfer the position of the guy, so to the DEC system, and from the DEC system it goes again to a professional alarm system. So this gives you already in places where you need it up to very precise locations, 50 centimeters maybe. Yeah. In a foundry like that, in this picture, for example, you have many machines or many fireplaces, let's say, one next to each other. And if something happens, unconscious alarm, for example, you need to know if it is on machine 4, port 5, or somewhere. You cannot say it's in hall 5, because then the accident might get even worse. If you cannot really say, please first help us run to this place. And with the beacon things, just add it to the DEC telephony solution, which is in place anyway. You can immediately provide that. So, of course, it's not enough. Good that we have customers, because customers say it's nice that you give us a position when there is an alarm, but we want real-time location solution systems. And real-time location solution, if you look for RTLS in Google, there's fantastic systems. Wow, what they can do. Yeah. In our case, we can also do near real-time location solution system, but we are bound to our existing infrastructure, which is out who knows how often, 10,000 times, 15,000 times, no one can say. We have sold so many M900 multi-cell antennas. There must be a huge potential to get extra location solution on top. Okay, but with our solution is not the 5 centimeter exact super real time a tenth of a second whatever system which gives you on a nice made map some people who walk around, etc. Yeah, so that's not what it is. But what we can give you is we can give you on our multi-cell, we can give you a position, also a live position, very important, which is accurate enough to say that it's very near this receiver now, plus a frequency of, let's say, around 2 seconds. Let it be 2 to 4 seconds. So 2 to 4 seconds, you can have a position of someone. Think about the elderly home again. If someone goes into the room, let's say latest 4, 8, whatever, 10 seconds later, you know exactly the person is in. Perfect solution, easy peasy. Cost of the solution in this case is deck this in place anyway. It's just one extra receiver and a handset which has a Bluetooth beacon enabled, or whatever beacon equipment which is existing already. So that is basically an add-on to a telephony solution you already provided, and the positioning, it doesn't come for free because you need the receivers, but doesn't cost the world, let's say. So what can we do out of this? We can do geo-fencing. Yeah, this very nice definition, which I will not read out aloud. It's basically someone comes in, goes out of an area which needs to be understood. Access control. Yeah. But more important, what people always ask, tracking. They want to track devices and people. And hopefully we have here we go. Here's one example, value protection. Let's say laptops, yeah? In our case, we also were quite unlucky. We had break-ins and laptops got stolen and things like that. And we have people asking us, you know, we have really important X-ray systems, and X-ray systems, mobile ones, X-ray systems get nicked, at least in Berlin, all the time. It's hard to hear, but yeah, that's how it is. And they need to be protected somehow. So what do? Very simple. We take one of these small tags, we stick the tag to the device or the laptop, and when the laptop or the X-ray system is moved, then this tag starts firing. Oh, I'm here, I'm here, I'm here. And in this example here, you can see that at the exit we have access or exit control receivers. It's the same receiver which we have anyway. And then the guy with the valuable, let's say, walks out. Alarm, the first receiver understands, the second receiver understands that he just came by or is within its reach, and like this we know that he's actually going out. There's a direction now. Yeah, first got detected here, second got detected here, so the guy goes out, and then something must happen. Alarm, automatic door close, whatever. Let's not think about shooting, but every imaginable measurement can be taken. And that works actually very nicely with those tags, because it works very nicely with the tags. That's how they look. When we can guarantee that there is in our laptop, for example, the laptop is not moved all the time, because as you can see, first of all, it's this small tag. It reacts on movement. It has a motion detector. So when it's not moving, then it's not emitting anything. It's not sending a ping. It's not saying I'm here, I'm here. That also means that it consumes almost no energy. So, for example, if you want to save one of your pictures in the office, or something which is normally in this room and should not be moved, you just stick one of those things, and when it gets moved, then this little tag wakes up, sends I'm here, I'm here, I'm here, while it's being moved, let's say, while it's shaking. And you can immediately understand my stationary object all of a sudden got moved, and I can react on it. Yeah, and after a while, when it's not moved anymore, the thing goes to sleep, just to save energy. So when you have something which is rarely moved, a simple battery, this is just a very common battery you get in every shop, so the typical round battery thing, can last easily 2 years. If it's moved very heavily, then it will last maybe only 2 months, because the battery, because it's sending. So this is not our application. Our application is something an equipment which is moved not all the time, but let's say often enough. Then with this thing, you can actually easily protect a year. If it's a typical, if it's an oil painting which should not be moved at all, even after 5 years, it will still react. Yeah, just that you understand. But the important bit is you put the tag somewhere, and if it's not moving, it will not send out anything. It will not consume energy. If you start rocking around, then it will send. It will be detected by whatever receiver, and that's how you can build your theft applications or whatever. So how is this working? That's actually a page from our online documentation, which I like because it's quite thorough, let's say. This explains it. I just recap a bit. Let's say I have a handset which is sending out permanent Bluetooth beacons, like here. Then number 2, our receiver understood the beacon, real-time position in this case, sends it over to DACT. The DACT system speaks a protocol over a normal IP network to the alarm server or alarm server solution, which you did on your own or which you actually bought from whatever professional alarm server people. The alarm server decides what to do with this alarm, goes again via the DACT, finds the final guide to alert, and creates whatever alarm messages, ringings, etc., all sorts of things. So you can see it looks like quite complex, but that's the way a typical alarm handling would work inside, let's say. And this is this is what you get. It's working. The important bit is always the alarm server. This is not Snom, and all the rest is basically Snom. So this is just the same thing when you want to start and use our demo message server, for example, which is not an alarm server but a message server. Then you have a figure like that, let's say. So now again, applications. Look for the nearest doctor. So typical hospital here, yeah. We will know when he carries a beacon emitting handset where he is. Most of the time, that is also important because also doctors get missing in a big hospital for whatever reason. Yeah, you never know. But that's quite good to know. Not that he's actually coming, but that he's not far away. Sometimes the decision is very important to which doctor to actually alert in an alarm case that he comes in time. Yeah. Unfortunately, we had things like that, so that's why it's not nice to know if it's not clear where the staff actually is, which helps to keep you safe, let's say. But it's like that. So tags again. So beds, they are the ideal object. They normally stand around, but they also get moved. So whenever they get moved from one to another room or to cleaning or to whatever, then it would be nice that we still know where the beds are. So in this case, very simple, put a stick to it, one of the tags, stick a tag to it, and you will have the last position of the bed every time. Depending on, of course, that you have Bluetooth receivers in rooms or in corridors, in front of the emergency room, in the cleaning section, etc. Yeah, but you definitely know. And believe it or not, in hospitals, beds they don't get lost, but they get missing. They maybe after weeks they find them somewhere perfectly clean, but put in a place where no one actually knew that it's there. Yeah, so this problem is really existing. But anyway. There's more alarm calls, of course. A doctor needs alarm calls. Here again, we have the professional people to do that. But now let's go to industry. It's not all healthcare we work for. Industry is also quite interesting. And this one I like most because we actually did that. So it's a steel production company, let's say, and they have machines which bend stainless steel into whatever form you want. Yeah, and it's quite impressive machines, quite heavy steel, let's say, and then you can basically see what you can do out of one steel plate. It's quite interesting. So what they wanted is they have many different machines with different purposes, let's say, and all the machines by stapler get their production material. And the production material, of course, needs to be there in time. And the overall ERP system is handling and steering the whole production process. So the stapler driver has his own device, so iPad scanner something size, and he gets his orders, which material to pick up where and to bring to which machine. So that's nice. It's all cool, but unfortunately, sometimes they do not know where the material really went. So they know that the driver, for example, said, I took this thing and sent it to machine 4. Yeah? But they cannot guarantee that it's really there. And it can be just a slightly wrong usage of the local device from the driver, or it can be any reason that all of a sudden the material sits around somewhere where it's not needed, and the production actually doesn't go forward. And of course, this costs money, so it's a catastrophe. So what they wanted from us is they wanted us to make sure that we can help them to track pallets and track the origin and the target position of these pallets, just to make sure that the ERP system, when the driver says I actually delivered, that it is really delivered. Yeah, and of course the next step would be that the driver doesn't even have to confirm anything, and everything goes fully automatic. So that was the task for us, and I can tell you it wasn't easy to do, but very interesting. And of course, there's another one. If you have person, you want to have the exact position, because something can happen. The stapler can run over someone, or the stapler runs into whatever low ceiling, which is quite common. And then something happens, and in this case, you have a conscious or unconscious alarm, and of course you need to know where it happened. So this just comes for free, yeah, if you do the pallet tracking. Okay, so here's the pallet tracking, the first test we did with the company, and this is just one of many halls they have. And as you can see, we used a small section, so 100 meters by 40 meters, and at these red things we put our receivers. And around the receivers, there are the machines which need their supply on steel, etc. And we try to find out where do we have where to position the receivers correctly, that we can guarantee for the ERP system that, for example, 1 ton of steel, this grade, was delivered to machine 8149, something like that. Yeah. So we tried that, and I just let that run here. This is just a stapler which goes around our test our test drive, let's say, and you can see from the online data that positions are changing. So the stapler is moving and the positions are changing. So what we wanted to find out, what device is the best to ensure that the stapler position is really known. Is it a tag, so like the round thing, the little one, which only reacts on movement? Is it a handset? That's in this case with my name even. Yeah, well, and or is it something something which permanently delivers beacons directly on the stapler? And surprise, surprise, we found out that if you have a beacon emitter sending permanently on the stapler, this is by far the best position you can get. The good thing about that is that the stapler runs on battery power anyway in this case, so you have no battery problems. You just connect it to the stapler battery and super. So we basically found out we can track a stapler quite easily when we make sure that the stapler itself is permanently issuing its position with a device which is mounted to the stapler and mounted to its power source. What also works is, of course, handset. So a handset for the driver, he can call anyway, and he can also use the handset to have the position. But he can somehow hide the position if he puts it in his carbon plated vest or whatever. Yeah. So that's why we decided a handset would be fine, but stapler is better. And tag in this case is not really useful, simply because the tag reacts on motion. Of course, the stapler is in motion, but staplers can also move very, very softly, so that motion cannot really be detected. So we had one stapler driver who was so skilled, obviously, that he managed to have the thing that it never shook really hard. So okay, good. So that was good for us to understand. From the prototype we built with them, or the test prototype we built with them, you can see here this is basically their web view, which goes directly into the ERP system. So they built everything like you see in the middle. They built on their own, but we provided the messaging server and of course equipment, and helped them with to get the positions out of our database, let's say. Yeah. And now we are shortly before Christmas, we will add the third hall to the system. So the one is expanding quite heavily. And for them, the decision is very easy. It's not something they super urgently need, but they can simply avoid machines which are not running full time. That's it. Yeah. They cannot avoid it 100%, but they can avoid it a lot better than before. And so we are quite proud of that thing here. So this one is really weird, because this is a pilot, like it says on top, more or less only to test the limits of our system. Like I said, there are real-time positioning systems in the market which gives you amazing data, at least from the data sheet. If you read it or if you see videos about that, it's unimaginable what's possible. Yeah. Since we know that we can't do that, but we can do a lot, we actually try to have something which is at the edge. So what is that? You can see this is some sort of cages where firefighters need to train. So firefighters need to go through these cages and to find the exit. And they do this not just in the cages, but if the room here is very hot and full of smoke, so you cannot see the hand before your eyes. It's really horrible. And so we gave firefighters, for example, tags on the helmet, decked handset just to carry. And then we thought, how can we position our beacon receivers in an environment like this, which is very narrow. This is like 1 cubic meter per block. So a block like that is 1 cubic meter, and then we have two levels of cubic meters where they have to go through, let's say. And we wanted, of course, to do real positioning. Here you can see it slightly, real positioning of the firefighter trying to get his way through the maze, and with the technology we provide. Okay, so we tried that, and just look at that. This is how a firefighter would actually try to go forward. Just remember, there's now no smoke, nothing, no heat, but it's still, there's a lot of things he needs to do, open up things, etc. And of course, some people don't manage, and some people get in panic, some faint, some whatever. And they also need, in this test environment, they also need an alarming system, let's say. If they know that the guy is not moving anymore or not reacting to that, because they're permanently on radio and trying to give instructions, if something is wrong, then someone needs to run into this room, even though the room is not very big, they need to know in which cage the guy is, because cages are quite complicated. You cannot open all cages. There's several emergency exits which only the people there know. So they need to know if, for example, the poor guy got stuck here, that they can only enter via that door here, for example. Yeah, and they ask us, can you give us precise, better positioning than the position we have with side and trying to remove smoke as quickly as possible from the room. And we tried that. Yeah, and I can tell you it's really hard to do, because 1 cubic meter positioning is close to is really at the edge to what we can do. So what came out so far, and we are still trying to optimize that, we can give a position. We cannot we can give a position very near the receivers. We cannot really triangulate or do whatever multilateration positioning without having a predefined path where the firefighter has to go along, and all things like that. So there's a lot we learned, and let's say this is too much for our system. If this would be 2 cubic meters, we would be good. But 1 cubic meter in a setup like that, like you can see, many receivers on a very small space, this we cannot do. So that is really the limit of our system. So where do you have a situation like this? I guess nowhere. Yeah. So that means just think about it. Any positioning in an office, in a company, in a hospital, in an industrial area, no problem. We manage. Yeah, we manage together with you. So what you get from all that? Okay. Ideally, you have the multi-cell system sold to your customer already. That's the ideal thing. And you just approach them and tell them, do you have an area within your multi-cell where you would where you need precise alarm, or a position because you want to know, for example, if people come or go, or if people if more than 6 people in the meeting room. Yeah, we have a Corona thing here, COVID, which actually counts people in the room and then gives a red light or something. Yeah, and or you go to your customer, typical office people, and tell them, with this tag and this extra receiver, we can at least automate an alarm if some valuables you have get moved or stolen. If you can catch the thief is a different story, but at least we can tell you when it happens. Well, why not? So this is what we have. This is what you basically know. That's the new one. That's the receiver basically, and that's just one example of a beacon sender. Yeah, our tag. You have the mobile devices, the handsets, which are which is the perfect device to be received by our M9B gateway. And then, of course, for those people who want to do their own solution to resell to a full vertical, we have the protocol of the messaging protocol between the multi-cell and whatever server solution, alarm server solution. So if you want to do your own, you get in contact with us. We give you everything. We give you a demo server, etc. That you, if you really really invest in a new solution because you know that you can resell easily, then we can help you with all that. So we did something because it's most of the time it's hard to explain what we have. Unfortunately, I did not manage to make a video for you. I don't know why. I guess I'm stupid. I don't know how to press the video button in iPhone, that it's not all the time pictures only, but that's my fault. So look at that. This one here is a simple breakout game you can get, in this case a Python version, and we wanted to have so this bar here moves around and the ball goes up and down, and what I wanted to do is to give all the positions for the bar
they get the M9B receiver position. Yeah. So you have the sender. This is in this case an handset, and then you have to play breakout. Ball comes down. You run to the middle. You run to the left. And let's just see how my marketing colleague Jason actually is trying to do that. Yeah. So of course you can't see what happens on the game, but you can see that it's not easy for him, because this shows you everything the system gives you. It gives you some delays you need to understand. Here you can see it live now. And that's, let's say, a fun way to understand positioning and the maximum capabilities Snom can give you. Yeah. If someone is interested in this solution and wants to play around with our stuff, he basically needs Python and all our things, then we can give him. The important bit here is that this solution, this fun game, let's say, if you manage to set this up, you can set up, that's at least I strongly believe that you can set up any customer solution imaginable, because here everything is inside. It's real-time positioning, well, real-time, 1.5 to 2 seconds delay. Yeah, it's real-time positioning. It's using DEC multicell. It's using our receivers. Is using a Bluetooth sending device. In this case, our handsets. It has everything imaginably. It's just, let's say, an elderly home with action. Yeah, just think about that. So if you're interested in that, let me know. Last not least, of course, do not hesitate to contact us. Christian is my colleague. Christian is actually helping me also very nicely, specifically on the beacon topic, because there's more to explain. It's not a phone. Yeah, there's you have an application in mind or a solution, and we can easily tell with our system, with this and this and this equipment, and maybe with this alarm server provider, you can manage, or you can do on your own, or it's so cool we want to do together with you. So. And I have, hopefully, maybe I have one more thing. Let me see if I manage. I'm sure you cannot see that yet, but this is really the last one, so bear with me. Where is it? Why can sharing? So I try to share another screen. Let me just see. Yeah, now you see that. If you have a multi-cell, a working one, you can do telephony. If you have the Bluetooth extra, you can do precise positioning. You can do real-time positioning. If you have real-time position, something is moving and you know where it is, of course you can do IoT. And just look at that example. There's a couple of examples we did our own. Yeah, using lights. So top left is the foundry where we installed everything. You can see if I move around, the light goes on. It could be a machine which turns on or off. We have a Corona system on the top left, which checks the air quality. We have our phones to control any device run with a professional KNX system, etc., etc. It's really up to you. So from the position to any IoT, any automation, business automation thing, it's a very small step. And even here, we have enough tools already to help you. So if you want to go the full way, not just positioning, not just alarm, not just whatever, but also controlling active devices, lights, etc., you name it, let us know, because we have a lot of things here too. Okay, so with this, thank you. I just check quickly. I just checked quickly the questions. Okay, there's one very nice question. How can you basically manipulate the strength of the Bluetooth signal. Yeah, there's many ways. On the receiver, you can say that Bluetooth signals which comes in with minus whatever 75 dBm is the one I still accept, and all the others I discard. That's one thing. If you have the handset, you can say that it sends out with lower energy or full energy or half energy. So like this, you can also adjust the distance. So the easiest thing on the receiver side is to say if a signal comes in which is very near, so let's say minus 60 dBm, yeah, then I accept it. That's the easiest one. So cutoff angle basically, and that always works. Yeah. Okay, then one more question about the how to move around the thing. Yeah, it's really every receiver M9B gateway is like a decked handset, so you can move it around and put it anywhere you want. It's really like a handset. It's a device, nothing else. Super simple. Okay, and not to forget that all this what we are doing here, we do this very long with a very well-known company in Denmark, RTX. Yeah, and all the application you see here is 100% Snom made. Yeah, so the important bit is that you understand the applications, and this is what we do. Yeah, maybe interesting for Ludovic to know. Yeah, and yeah, so thank you a lot. Thanks a lot. And yeah, if you want to try it out, if you want to do whatever understanding fun game or implement Pong, let me know. If you have a hospital waiting for positioning, let me know, let sales know, and then we move forward. Thank you.